Dear ladies and gentlemen, in this video I am going to show you the initial setup of the database for the Dream software. We will set up segments and assets and see how it is done in the Dream software. So to start, we need to find the Dream software and start it like this. Yes. We select the database that we have created in the previous video and select a site that we also created in the previous video and say OK. When the Dream will start, it will load the database and will ask for the password. The password that is set by default to the administrator agent that has the full capabilities and full possibilities is 4 zeros. So we enter 1, 2, 3, 4 zeros, 0, 0, 0, and login. This password and the name of the agents is set up in the Dream software. So just we can go after we started the first time or any time, we go to the reference data and we have agent management and we have administrator here and we can edit it, and here is our password. I, for example, can delete this password at all or set up any password that I would like to have. Also here I can add some agents and give them some roles, etc. Additional video will be devoted to it. Just now I deleted this password and start the Dream software. So here is the list of my equipment that I have in the database. It is not set up yet and we are going just to do this. So I right click here and there is a local menu and I can add something to the database. The choice is to add a segment or to add an asset. Usually a segment is some logical entity that has some role in the enterprise. It can be production line number 1, it can be feeding pump, it can be turbo generator number 3 or something like this. The asset is a physical entity. We will make diagnostics of the assets that belong to some segments. The asset can have an serial number and we will make diagnostics of it, we will make condition monitoring of it, we will do the measurements on the locations of this asset. So first I suggest that we set up a segment. The segment should have a name. For example, it can be pumping station. And it may have a type. We have a list of the possible types. We can say that this is production process, that this is pulp production, or we can say that it is undetermined. This will be presented in the reports. Also, we can have a command here, just to enter any command that you would like to have, that this operator Jones is responsible for it, or anything else. Okay, finish. So this pumping station is on my list. This pumping station may have a few pumps. So let's do the pumps. We add here, for example, a segment that will be pump of the low pressure. Low pressure pump. Type, for example, service segment. Okay, finish. Low pressure pump. In this low pressure pump, we may have also many pumps, for example. We can add here already an asset and we will make measurements of it. For example, it can be low pressure pump number 1, like this. Type, let it be again undetermined. Okay. We can enter the model, serial number, etc., etc. We will see when we need it and why. Finish. So, we have a pump, number 1, it has some serial number, this is an asset, and we may have a drawing here, and for this we can set a user map folder. Here is the view and the list of the views that we may have in the database. So I select the user map, and here I can set an image. For example, here I have a drawing for my pump. I can select one, add a new drawing. I can find this file on my disk. I have, for example, some folder here, and I have a drawing of a pump. Okay. Name low pressure pump. It's the name of the picture. It will be a drawing. Okay. It has a format of JPEG file. Okay. Okay. This is my drawing. Okay. So let's see. Suppose that this is a pump. The pump consists of a motor and a pump itself that is connected with some couplings. The motor itself consists of non-drive end bearing, drive end bearing, and the electromagnetical part of the motor, some rotor, stator, etc., etc. The same with the pump. I have two bearings, drive end bearing, non-drive end bearing, and I have the impeller. All these 6 entities or assets we can make diagnostics of. To do this, let's start with the setup of the bearing. Here is the bearing, non-drive end bearing, and we add here an asset. It will be non-drive end motor bearing. Type. Now we would like to select from the diagnosable types. So we have the automatic diagnostics modules for these very many different types of the equipment, and we select bearing rolling, supposing that this is a rolling element bearing. Then we need to select a model. The model of the bearings will be the sizes, will contain information about the sizes, and then we can calculate the bearing frequencies. And we can set up the measurement automatically, knowing the dimensions of the bearing and knowing the parameters of the rotation speed. So for example, here we have only one bearing in our database, but if it is not the one that we would like to have, we can import the bearings from the database, from quite a big database supplied with the Dream. So we go to the we need to find the place where the Dream was installed. You may know where you have installed it. I have installed it in the program files in the Dream 5, and here I have the bearings folder. I select from the English, and suppose I want to have an SKF bearing, so I select a file from the SKF, open it, and there is a few thousands of the bearings of the SKF production. Suppose that we would like to have 6405 bearing, and we import it. So now this bearing will come from the general SKF bearings database to our local database, and we select it. We can also see the numeric data. Numeric data, this is the sizes of the bearing. For example, the inner race diameter is like this, outer race is like this, 7 rolling elements, and we say that, yes, okay, this is our bearing. Okay. And that's it. We have finished the creation of this bearing, non-drive end motor bearing. We can say here that this bearing belongs to or resides here. That's it. Non-drive end bearing. Then we can do the setup of the measurements for this very bearing. To do this, we go to the bearing and we go to the configuration. We have measurement locations, we have measurement setup, and we can do the setup of a new measurement. Add a new setup. So this is, first we select the instrument that we have available for these measurements. We select the instrument DC23, and this is the list of the measurements that DC23 can measure. Let's start with the overall level. Overall level is a general vibration level selected in some frequency band, and we can set it up for 3 directions, for vertical, horizontal, and axial. To do this, we need to configure the 3 directions, and we do this, and we generate the names. It will automatically generate non-drive and motor, horizontal, vertical, and axial. Say OK. We go to the setup of the vibration levels, and here is the general setup. We select the frequency band. The ISO standard frequency band is from 10 to 1 kHz. We can make measurements in many units. For example, let's make measurements in millimeters per second, linear scale, AC coupling, and a few samples to get more stable results. I suggest that we make 4 samples. We can also do it RMS, peak factor, kurtosis, etc. RMS is the standard in ISO. Finish. Now we have set up a few measurements like horizontal, vertical, and axial. We have no measurements there, and it was created today. So this is one way of measurement setup. Another way of measurement setup is that we can set up diagnostics. In this way, we go to the diagnostics folder, and this is automatic diagnostics and automatic setup of these measurements for the diagnostics. So what we can do, we can add new diagnostics for these units. So we have available types of the diagnostics for the rolling element bearing. You see that we have a very big list of the diagnostic possible. Here we have rolling element bearing and shaft line. Usually if you have a coupling, you can, in the machine, you can select rolling element bearing and shaft line. We copy the name of the diagnostics because we can make diagnostics of it as a rolling bearing and shaft line, as a rolling bearing and gearbox, etc., etc. To set up the measurements, we need to know the rotation speed of the machine. Suppose it is 3000 RPM, and we enter that it rotates from something like 44 up to 50 Hz. If it is an induction motor, then it is a normal deviation for the rotation speed of the induction motor. Variation and maximum variation of the rotation speed, this is the program will find the rotation speed frequency within this percentage from the number you entered. So we go next. If we have a paired bearing, for example in one bearing shield we may have a radial bearing and thrust load bearing, then we can enter another paired bearing in this bearing shield. Suppose we do not have it, and then we just go to the next. This is the list of the defects that the software can find automatically, and the levels for the defects that it suggests. You can edit it, but I suggest that we leave it as is. Percentage, this is percentage of modulation in the envelope spectrum. So we will need to set up an envelope spectrum and the normal auto spectrum. So percentage is the levels for the percentage of the modulation or modulation index in the envelope spectrum. dB this is increase of levels for specific lines in the auto spectrum compared to the previous results. So we go to the next, and it suggests us to select the measurement location. So we have 3 measurement locations, and I suggest that we will make a vertical location. So we can select any measurement location from the database. I suggest that we select a vertical and say OK. Finish. Let's see in the configuration what have happened. We have previously we have set up 3 overall levels, and now we have automatically set up envelope spectrum with these parameters and auto spectrum with these parameters for the diagnostics of this machine, of this rolling element bearing. This is automatic setup. Now we can return to our pump, look at the picture, and say that we have set up this node, this bearing, non-drive end motor bearing, and suppose that it is the same as the drive end bearing, then we can simply copy it. Copy this one, copy, and paste it in our pump. We select paste and say that this is drive end bearing. We copy it without measurements because we do not have any measurements, and say that we passed it. Now we have drive end bearing and non-drive end bearing in our pump. And what we can do else? We can do the motor itself. So we select our pump and add here a motor. It will be asset. Next, motor. We have a type. It can be induction motor. Let's find it. Motor, accelerating current, alternating current, induction. OK, in the model. We need to set up a model for our motor so that it will be possible to make diagnostics of it. Name, motor of a pump. Next, main supply frequency. Suppose that it is 50 Hz, that is in Europe. Number of rotor bars, you can look for the number of rotor bars in the manual for your motor, for example 40. Finish. OK. Finish. Now we have also a motor here. See that this is a motor. OK. And we can make also diagnostics of the motor. We go to the diagnostics folder and set up a diagnostics. So we need to cancel. We need to select a motor and make diagnostics for it. This is the list of the available diagnostic modules. So we have diagnostics modules for the induction motor. We say that the rotation speed is the same, from 48 to approximately 50. Next, this is the list of the defect. You see that we can find defects of shaft supports, static eccentricity of air gap, dynamic eccentricity of air gap, etc., etc. Next, now for the motor we need to have 2 measurement points. One measurement point is a standard one. You just can call it radial. It is in the radial direction. What type? Type is the vibration, absolute, on casing. Okay. Okay. Another should be in the tangential part. This is parallel to the case. So we call it tangential. We'll also say that this is vibration absolute. Okay. And now we have 2 points. So normal for the radial, and for the tangential we select tangential. Okay, finish. Now we have created diagnostics for the induction motor. We can look at the configuration. You see that in the configuration we have 3 measurement setups for the diagnostics of the motor, and we can continue diagnostics or can continue configuration of our pump. So what is left? Left is the pump itself. We can also do the 2 bearings. For example, we do the asset pump. It will be drive end pump, type bearing rolling. Okay, model, let's select a different model. Okay, finish. Drive end pump. We can select we can do the diagnostics here as well. Cancel. We need to select this drive end bearing on the pump. Make a diagnostics. Rolling element bearing and shaft line. $48.50. Next, next, next. Measurement point. Copy it. Oh, drive end. Select vibration absolute casing. Okay. Okay. This one. Okay. Finish. Let's go to the configuration, and we have a couple of measurements for the diagnostics of the drive and bearing of the pump. We copy it and paste it to our pump and say that this is non-drive end. Okay. And we create here, we also create a pump impeller itself. So here we have drive end pump, non-drive end pump, and let's create the pump itself. Add, asset, next, pump, type. Let's find the pump here. We have a pump, model, new model, pump, next. What we need for the diagnostics, we need the number of impeller vanes. For example, let it be 6 vanes or blades. Finish. Okay. Finish. pump. Here is our pump impeller. For the pump impeller, we can also make the diagnostics, new diagnostics, pump impeller, the same rotation speed, 48, 50, next, measurement point, create a measurement point, vibration, OK, OK, select it, OK, finish. If we go to the configuration, we see that we also have two measurements, envelope spectrum and auto spectrum. So now we have created our pump with the whole list of measurement points, and to make measurements of it, we select it, right click, and here we have a command measure. We press it. We can create a route for our pump. Okay. This is the suggested name. Yeah, pump number 1. Okay. This is the route that has all our measurements, and we can download it to the data collector. To do this, we go to the hardware and select our instrument that we have here. This is the list of the routes in our database. This is the list of the routes in our data collector. We need to connect it, and then we can download. Here we can see all our measurements that are done for all our points. For example, we have created for the bearings horizontal, axial and vertical measurement point, and we have created overall level measurement in 3 directions, and envelope spectrum and auto spectrum in vertical direction. The same that we have copied for the drive end bearing. For the motor, we have also 2 measurement points, radial and tangential. We have to measure something in radial, we have to measure something in tangential, and the same for the pump, for the pump itself, and for the bearings of the pump. Now we can download this route to the data collector. I will show it to you in the next video. So for now, thank you for your attention. Welcome to the next video.